Sensor technology has been around for some time in agriculture, especially in the hands of cropping farmers. An imaging tool originally employed in space exploration and on military operations is now being used at Massey University to enable better on-farm decision-making.
There's been quite a long history of having sensors available. I think the capability of the sensors is improving all the time, both in terms of, I suppose, we talk about the spectral range that they have, how much of the spectra they can see and how many wave bands they can see, but also in terms of their spatial resolution as well. So we've gone from sensors that would sense a single point in a paddock to sensors that we fly, and we can put a very detailed map of a paddock, and we can do that at multiple spectral levels. So the level of sophistication is really increasing. And I think what we're seeing now is the level of use, or the level of capability is increasing, that a lot of these sensors are now becoming more useful to farmers. Most of the sensors that have been used have been to inform nitrogen application in cereals or maize crops in New Zealand. In the States, it's mainly maize and the main crops that they grow. And a lot of it's been around informing nitrogen decisions for farmers. So I guess what's different to what we're doing is we're looking more at pasture. It reflects more the agriculture of New Zealand. So again, there's been a bit of focus on nitrogen, but also now, because of the capability of the sensors, we can look at other nutrients as well, and we can begin to build a much bigger picture of what's actually happening with our pasture production. The main project that we're working on at the moment is a PGP project. That's a Primary Growth Partnership project, and it's funded by Ravensdown and MPI. What we've done there is put an imaging system in the sky that can tell you basically what nutrients are in your pasture. So it's almost like doing a herbage test for every square metre of your farm. It can tell you the nitrogen level, phosphate, all of your main nutrients. We can work out the concentration in the pasture. We can tell you the dry matter, we can tell you the ME. So that's where the technology is at the moment. We've been in it just over a year. We've been testing the technology. We're extremely pleased with how the testing has gone in terms of being able to build robust calibration for this sensor. It's an expensive piece of equipment that has to sit in an aircraft at this stage. It weighs 75 kilos, so there's no way you can put it in a drone or something like that at the moment. But it's got tremendous power and we think tremendous potential. The technology that we've purchased was from Finland. It's a company called Specim, and the sensor's called a Phoenix. I believe that there's been a lot of military applications for this type of technology to identify tanks, and people camouflage tanks, so we've got to find better ways of finding them. So to look at space exploration, it's also been used through telescopes to look at space exploration and find out what is actually the matter in space. So it's really, I think, from those sorts of applications, people have realized that it's got huge applications on either farms, civil engineering, exploration for minerals. All of those sorts of areas has, I think, a tremendous future. The main focus of the PGP project is really to try and improve fertilizer application to pastoral hill country farms. So there's two parts to the project. One is that we've got an aircraft that we're making better use of the technology in the aircraft to control the application of fertilizer. So one of the things we realized was that we need to be accurate in how we spread fertilizer, because there's no point in, we can have the best sensor in the world, but if we make a horrible job of spreading, then there's no point. So that's one part of the project, and that's a project that's been separately funded by Ravensdown, and we're working with them to do that. So the second part of the project is around the sensing part. And as I say, the idea is to better inform our fertilizer application. So how productive are different areas of the farm? What's happening in terms of the nutrition of the pasture? How can we improve it? So that's kind of if you like, getting the technology to recognize what's there is the first part. Now we've got to work out, okay, well, how do we maintain it? How do we improve it? How can we help farmers make decisions around, okay, which areas of the farm do I try and improve first? Because they can't do it all at once, and we've got to try and help them to really say, okay, well, where can I make most difference most quickly? And I think that's a lot of the value of the technology. They can really start to target their inputs and improvements that they make. In terms of the project, we've completed 1 year. We've sampled 4 farms, 4 large properties. We've done some of the farms multiple times, so we can understand and look at how consistent is the sensor, what's changing within the seasons and so on the farm. What we're doing as well is ag-research are also involved, and we do a lot of measurement while we fly. We do measurement on the ground, and we use that to calibrate the sensor and also validate the sensor. So there are sites on each farm. There are 400 sites on each farm that we cut the pasture, we send it to a lab, we take the measurement with the thing that looks like a bin. We use that to take field measurements. That sample goes away to the lab to be sampled as well. And then we will also use other technology to validate what the sensor's seeing. So that's really the main focus, and it's quite a time-consuming, labor-intensive job, but that's what we've got to do to show that the sensor can work in multiple situations. As far as cost is concerned, say $10 a hectare, we think we're pretty close now that we could do it for that type of figure. That might sound a lot if you've got a few thousand hectares, but in terms of your fertilizer bill, it's obviously a lot more than $10. So if you can make better use of your fertilizer, say of your $200 worth of fertilizer, by investing $10 per hectare, then it seems to me that that starts to make some financial sense.
This program was made with funding from New Zealand On Air.